So good afternoon, everyone, and welcome to the latest Engineering Insights webinar. I'm Simon Evans, a director at Burn Sheehan, and I head up the software engineering team. I'm in quarantine at the moment, having returned from holiday, and due to an imminent Ocado delivery, I've decamped the bedroom, so apologies for the wallpaper. We've run many of these webinars during lockdown, which you can see on the Burn Sheehan YouTube page, and I'm really excited to introduce today's speaker, Mario Giuffrida, who is a tech lead at Tesco. He'll be presenting Effortless 10,000 Step Functions a day, discussing the journey that Tesco took when introducing AWS Step Functions into their tech stack. He's happy to answer any questions you might have, so please use the Q&A function and he'll go through those at the end. Mario, over to you.
Yeah, thank you, Simon. Thank you. Hi, everyone. Let me share my screen. Here we go. Okay. So I'll take it. You can see my screen, so I'm happy to start. So hi, everyone. This is a presentation, is a brief introduction on AWS Step Function, and as Simon explained, is a little bit of background of what happened to us, and the experience, and what was our what we have done with the Step Function. So this talk is about the why we may need Step Function. And this is the first point. And also, what are the step function, and what has driven us in Tesco to actually use them, and also our experience using step function, as I was telling before. So what we found really good, and what instead needed was a little bit of a compromise, and then I'll show you a little bit around step function, and even seeing a little bit of AWS console. And now, let me start with a little bit of a story. So let me find my mouse first. So I wanted to tell you, so just a little bit, a brief tale here. So Italy unified during a period called Risorgimento, and unified in 1961. And what was funny back then was that they needed, once Italy was unified, they needed to choose for a proper flag. And what they did is they copy the flag from a cockade that first appeared during a demonstration in 1789 during a French demonstration. Now, apparently the green is like a misinterpretation of the blue in the French flag. But yeah, so it came out as a cockade, and with the color of the Italian flag. So during that period, some historians tell the story that the Queen Margherita was like, she grew tired of the normal gourmet and French cuisine. So during one of the visits in Naples, she was very curious to try this pizza. So she asked one of those pizza maker there in Naples, and she asked and say, okay, I want to try something different, so let me try one of those pizza that you do. And of course, what this pizza maker was back then, the history tells that it's called Raffaele Esposito, made one pizza for the Queen. And the first pizza was like a marinara pizza with anchovy, and the Queen, she wasn't impressed. Then she tried, the second attempt was a Napoli pizza, what today is called Pizza Napoli, and it was with anchovy. And apparently the Queen, she wasn't impressed either. So that on the third attempt, she thought of doing a pizza, and using the color of the newly formed Italian flag. And so she used like she did this pizza, and she put like tomato sauce, mozzarella, and basil. And apparently the Queen, she liked a lot this pizza. She really enjoyed it. And so you can now understand how was that this was basically how the pizza margherita was born. Why why I'm telling you this story is because this connects to another little story that I have, and this is basically where I'm coming from. Um, I'm coming from Sicily, and back then in the 90s, there was a friend of my dad called Giovanni that he basically opened a shop, and for the 90s, it was very innovative shop. So inside this shop, there was like a big room, and inside this room, there was like a conveyor belt. This conveyor belt basically has like different stage, and do basically a pizza for you. It was like an automatic machine that do the pizza literally in front of your eyes. So you can see, you can follow the flow of this conveyor belt. There was like a little window there in this room where, you know, all the clients, all the customer of Giovanni, they can go there and see their own pizza being made by this automatic machine. And back then was an amazing concept. And remember, this was the 90s. And the pizza was like tasty, crispy, thin, and full of ingredient. And you can imagine all of us like little kids there, very exciting, waiting for the pizza to be done. And the pizza was actually delivered in approximately like 7-8 minutes. It was amazing seeing all this. Now, um, now, this is not a picture of Giovanni, but you know, there was nothing else that I found, and of course, I cannot find his original picture, but this can give you the idea. Now, Giovanni was very famous, was the hype of the moment. He was making a lot of money, and actually was making million. He had a lot of loyal customer, and when I say he was making million, he was literally making million, because back then, in today's value, 1 pound was 3,000 liras, and the liras was the old currency that we had in Italy. So it was like literally basically making million. Now, the hype increased, and there were like a lot of people queuing for Giovanni's shop. And but you know, when the number of people went over the tipping point, a tipping point, what happened is that the queue was a little bit too long, and you know, the promise of having a freshly baked pizza in a timely manner was not honored anymore. And basically, was the first time that where Giovanni realized that his machine, pizza making machine, was not able to scale. So he was very worried about all this. So what he did was like he started making some sort of, as he was losing, you know, client, customer, he was start making a little bit of improvement to his machine. So he experimented a little bit with the pizza base, and he tried to make like a thin and thick pizza. So you can see, depending on how long it took to flatten the dough, he can have like if he flatten the dough in 2 minutes, is more thin, or if you use just 30 seconds, is more thick. So he started introducing this option. For example, you can choose if you want like a small or a big pizza, or you can have option different ingredient. You can specify what kind of pizza you have, because at the very beginning it was just a margherita. And also, as the flow of people with time, it became a little bit sparse. Even the oven was not keeping the temperature continuously, because it wasn't working continuously. So Giovanni has to introduce like a little temperature feedback of the oven, and eventually, you know, delay this whole process a little bit in order to give time to the oven to reach the right temperature again. But you have to consider that every time Giovanni was making like an improvement, he needed to stop the whole machine, he needed to halt the whole system, and he needed to change something via hardware, or changing, you know, the pizza maker, or changing the owner. This take the whole system to be down. And also, because there were not so many people, keeping the whole system on with the sparse flow take a lot of money, was not efficient anymore. And also you had to pay the rent for the premise, the electricity, the maintenance. And so all this, of course, you know, the end of this was not yet to close the shop. But now, let me ask you to make a little effort here. So what are those steps in the pizza making process? So for example, so here we have the yeast sprinkler. So those steps is like we have the flour setter. So if we name those steps, they are really function. So we can see every single step of this in the pizza making as really as a function, as a state, and as a function that is run into the state. And so we need to, in this pizza making machine, is defined the flow. So we know that after the yeast sprinkler, it comes the flour setter, and then the flour mixer, and then the kneader, and then the dog puncher. So actually, this is part of the flow. So between those functions, there are those arrows, or in our example is the conveyor belt, that define the flow and define what happened after one function, what happened next after one function finish. Now, this is a very simple flow, but even in this simple flow, it's suppose that I magically remove all those functions, and I want just to show you the infrastructure required for this simple flow. So as you can realize, even if the flow we are analyzing at the moment is very simple, the infrastructure required and the flow to connect the different functions is quite big, is quite involved. And you need to consider that in this initial flow, there is only one exception that we have handled. And this exception is when the oven temperature was not the correct one. And we needed to wait a little bit more for the oven temperature to raise again. And we are not even considering here, you know, Giovanni's problem where he was not able to scale. And so we are not considering here, you know, the possibility of a function to be retried, for example, if it doesn't succeed. So now let's go back. I'll ask you to do one little step further. So even if we don't know what the AWS step functions are, I want to show you the step function related to this, to Giovanni machinery, and I want to check with you what jump out of the screen. So this is the state machine and the step function that I can define for this process. So as you can see, we have exactly the same function. We have the yeast sprinkler, we have the flour setter, we have the flour mixer. All this is streamlined here. So I think a very first thing that we notice from this design of the step function, from the step function here, is that it's very UI friendly. So here, there's a lot of confusion with what I try to explain here with the flow, the name of the function, but here is very well streamlined. You can see that after the oven starter, this is the kneader. Then we need to wait a little bit for the dough to raise. And then we have the function dough puncher that flatten the dough. And then we have the base ingredient topper, etc., etc. So we can easily notice that it's very much UI friendly, and it's easy to explain to other people. And also we can notice that we have the possibility to define a parallel execution. So the yeast sprinkler and the flour setter can happen at the same time. Another thing that I want to bring to your attention is that here we have a loop. So we go to the baker, then we have a multi-choice state, and then we go back to the baker here. But let's go into more detail. And now let's try to dissect this sample step function. So we start. So the first thing we notice is here, like the flour mixer or the yeast sprinkler, those are states. In particular, in our example, those are task state. And this introduces us to this feature. So we have different kind of states. Here in my example, we can see task state, for example, flour mixer. We can see parallel states, so two states that execute at the same time. We have wait state, and we have a choice state. So depending on the input and a particular condition, I can choose one flow or the other. And we have a pass state. Pass state is a state where I, for example, want to add something in the data, in the state machine data. And a succeed state, for example, is the presenter. This is an end state. This is when our step function basically finish. And one state that is not represented here is a map state, where I can run a set of steps for each element of an input array of this map state. So it's not surprising that this very first set of components of the step function are called states. Those are the states. So there are three main sets of components for a step function. State is one of these. So to define a step function, I need to define the states that that are part of the step function. Now, another logical step ahead is I want to tell which one is our initial state. So when we run the step function, what we execute first. This is defined with a configuration called start at. And then I want to even define, what come next. So one step is finished, what come next? And I define this with the configuration called next. Then we've seen before that we can have states with multiple transition. And here we go. We have multiple transition rule here. And we have a step that is the end of the step function. And here we go. End at succeed or fail. So basically this step will tell me that there is no next. There's no next step once we have reached here. So how do we call this set of components? We call this set of component transition. So transitions is the second of the three main set of components that help us to define a step function. The third and last set of components that allow us to define the step function is, unsurprisingly, the data. So we want to know, what data those functions work on. And in fact, we have in the step function, we have the input data that we provide at the start of the step function. We have the state machine data here, and we have the output data. This very last part of configuration of the state machine is called state machine data. So we have seen that to define a step function, we need those three things. We need a definition of the state, a definition of the transition between the state, and a definition of the state machine data. So now let's not forget now what's the main focus of this presentation. And the main focus of this presentation is actually helping Giovanni. What could have helped? Would the AWS step function have helped Giovanni with his pizza making business? So let's see. Giovanni, so the AWS step function has a way to sequence function. So you can define in sequence function. So this is what Giovanni conveyor belt was doing. Has a way to parallel execution, to make parallel execution. And this would have speeded up the flow in Giovanni's case. And also you can choose flow based on data. And you see that the data can be, for example, the different pizza ingredient. At one point, Giovanni introduced this thing to do different kind of pizza. So you can choose the flow depending on the pizza ingredient as well. at one point, Giovanni was introducing the error handling. So, for example, when the oven temperature was not high enough, he was like checking with a temperature feedback and then eventually staying in this state a little bit more. Step function allow error handling and even allow retry. So for example, if one of the functions does not succeed, then you can retry many times. You have a way to specify how many times to retry and for how long. So it's a fully managed service, so Giovanni doesn't have to pay for maintenance or do the maintenance itself. And then also with Step Function, you pay for what you use. So if there are no customers, you don't use it. And also automatically scale out on demand, so you can configure for scaling out automatically. And also the hot swap component. So Giovanni was stopping the whole flow every time that they needed to do an improvement or needed to do maintenance. Instead, with the Step Function, this can be done in a hot swap way. So how the Step Function helped us in Tesco? So first of all, in Tesco, it's very important, of course, not lose data. And so the Step Function manage state, checkpoints, and make sure that the application execute in the order and as expected. And so there is a less boilerplate in connecting all those functions. So the function doesn't know about what comes next, but you configure this one directly into the infrastructure. Those are auditable. Everything, in fact, go into CloudWatch from the output of every function executed in the AWS Step Function. And so we saw that it's very visual. This bring, of course, it's easy to explain and to explain to others and to collaborate. It's easy to build, operate, explain to others, and to make change. So this, in summary, gave us the flexibility to evolve easily inside Tesco. So we configure the Step Function, we populate each step, we say, okay, what we need to do in each step, we run the Step Function, and then we have the loop and evolve as the require need, as the require and the specification change. Now, let's go a little bit more into the detail now. I want to show you what does it mean practically to configure the Step Function. Let me do premises. Before I want to tell that to configure the Step Function, we use the serverless framework, that is a free and open source web framework written in Node.js. And so this was actually the first framework that was developed to build application in AWS Lambda. And using this framework is, so the framework is mostly cloud agnostic. So even if I'm talking about AWS, you can use the framework, most of the framework, to deploy into cloud, Google Cloud or Azure. Now, the configuration that you do using the framework is in YAML. So I'm isolating here in this slide the configuration specific for the Step Function, and I've filtered out the configuration that is related to the vendor, the cloud provider. So here you can see that we have the startup. So here we have the pizza machine is the name of my Step Function. Here I define a more specific name where I had my service name, and I had as well the provider, the stage of the provider. But here I want you to focus on this definition of the Step Function. So you can see that we are telling in the state definition where to start. So which is the first state we want to go right after the state machine is started, which is the base preparation. Then the base preparation is here, is defined here, and you can see that the base preparation is a parallel state, as we could remember from the diagram we have seen before. And as well, you tell, okay, once this state is finished, you specify the next state is going to be the flour mixer. And the flour mixer is defined here, and so on. This is a task state, etc. What those functions work on, what are the data? Those are the state machine data. So for example, the parallel state, the output of the parallel state is put into the state machine data is composed of JSON. So the output of the parallel state as specified here is going to be inside this path called base preparation. So it's inside the same JSON that compose the state machine data, but in this particular path. So let's zoom in a little bit more into a very simple task state. And this is, I'm going to zoom in this flour mixer state. So this is the flour mixer state. So what you can see in this flour mixer state, you can see there's a state name, flour mixer. There is a comment, of course, that is optional. There is a state type, so it's a task. So I'm telling inside this state, I want actually to execute a task. And here is the resource that I want to execute. This is actually the resource I want to run. In my specific example, in our project inside Tesco, we are running Lambda, a series of Lambda, but it could be most of other AWS resource like AWS Batch, Fargate, or SNS SQS, or AWS Glue, etc. The result path is where I want to add the result. So in which, what will be the path of my result? Result path is as well as input path and output path. They're really useful because you can filter exactly what data your function will be working on out of the whole set of state machine data. But they can be dangerous as well, because if you put here the wrong result path, or you don't put any result path here, you may overwrite the whole state machine data. And of course, you can see here a next. So next is what happened once this state complete. It goes to the next state called oven started, and so on. I wanted to show you another state, which is a wait state. So here, wait state, again, you can see a name, you can see the type, this time is defined as wait, and you can see second path. So second path is basically how many seconds. So I'm giving you the path of the variable that tell me how many seconds do I need to wait. And this variable is a path basically inside the state machine data. So is one section of the JSON that represent the state machine data. Again, I have a next state here, dog puncher. So when I'm finished waiting, do I have a next state? I wanted to show you the last, another actually example of state. It's a very simple state. It's a succeed state. So there's a name that is the presenter, so which is actually when I go out and present the pizza as a result. And here I wanted to highlight that the type is a type succeed. And also I wanted to highlight that there is no next state, because this is when actually the state machine has finished. Now, let me show you some screenshot of actually the AWS console. So suppose that I go to the AWS console and I search for step function, and there I can see in the list my step function, the step function of this example, which is called pizza machine. Step function demo is the service name, and dev, of course, is the stage. So here we got some additional information, like when the cloud formation happened, so the creation date, and also if it's running, if it succeeded or failed, depending on the number of instances that succeeded or failed. If I want to start one step function, I can do, no, actually, if I click here into the step function itself, I can see the execution. So I can see an history of the execution. This is the ARN of the state machine. and this is actually the execution ARN of the state machine. And if I want to start a new step function, what do? I click on Start Execution, and on Start Execution, this is where I'm giving the possibility to put data in input. So those data in input, those are optional, but those data in input, they are what they will constitute at the end, what they will become state machine data. So this is the very initial point where I put data in input. They will be persisted, and they will be available throughout the whole state machine flow, unless some of the function reset and cancel those data. As you can see, in input, I'm providing like all the ingredients of the pizza and the yeast type and the flour type. This is the flour mixing in seconds, so for 3 seconds for the purpose of this demonstration. And base topper, so the base will be topped with just tomato sauce. Instead, the other, on the second stage, I will add grated mozzarella and cheddar cheese, egg, mushroom, and ham. I will do the capricciosa pizza. So once this is complete, I can click on Start Execution, and then you are projected into this visual workflow. This is very useful because you can visually see the running of your step function. So you can see, you know, the green state, it means that they have already succeeded. So the parallel state has finished, flour mixer, oven started, they already succeeded. And then you can see, as we move on, we can have a wait state. That means that is in progress. So the blue one means that is in progress. And also we have other color code here. The red one, it means that those states are failed, or the state machine has failed. Gray is canceled, and amber is that an exception has been caught. So now the state machine is finished. What more I can show you is that if I click on one of these states, this is very useful, we show you the step, the detail related to this single step. So I can see the resource that was run, but also I can, if I click on input, I can see, you know, what was the input of that specific state. And the same thing for the output. If, of course, if he has run already, I can click on output, and it tells me what was the output of that state. As you can see, the input is again JSON, and what we have found very useful is marshalling and unmarshalling all just the information that we needed out of this JSON. In recently, the way to display those information in the AWS console was changed, and instead of seeing this click through input and output, you can see as a tab, but the information are the same. If I scroll a little bit down, you can see the execution event history. So this one will tell you exactly what was executed, which state were executed, and this is very useful in the case where you have retry, or you have exception that has been raised, or where you have state that can end up in multiple follow-up state depending on specific condition. So, okay. So what's more? What was interesting for us? For us was very interesting the encryption used inside the step function. So the data is encrypted at rest using a transparent server-side encryption, so the user doesn't have to do anything, but is encrypted even in transit. So when you're going to call other AWS service in transit, the data are automatically encrypted and using the transport layer security. So you have this kind of in-transit transition between all data that pass between step function and integrated service inside AWS. We talk about scalability. We can scale out on demand. As you can see here, we have 2 executions running at the same time. So you can configure a trigger, an event that automatically raised a step function. And in our case can be that, for example, we have, in Giovanni's case, can be that we have a number of clients, so it can start scaling up and scaling out and having multiple step function running at the same time. In our case at Tesco, we start scaling out when we have a number of pending message into a Kafka topic. Once we reach a number, when we have more than a certain threshold, we start scaling out and having multiple step function running at the same time. We briefly mentioned about error handling, and this is another important feature of step function, because it's very easy to configure error handling from inside the infrastructure, the definition of the step function, and also defining the number of retries. But before, one question: why we want to handle exception in the infrastructure as opposed to the Lambda code? Well, for our experience, we found that it was easier in this way to raise the level of abstraction. So in this way, we configure the Lambda, and we don't handle the exception inside the Lambda itself. So the Lambda, this made the Lambda much more reusable inside the as a Lego bricks inside the step function, and then we configure, the retries and the exception independently. But I want to, of course, giving you more detail of this error handling and retries, because this one was a very important aspect that helped us in Tesco. So in order to do that, let's introduce in this state machine of preparing a pizza, let's introduce another step here, another function here. And this function will be like a quality control. Now, you have to know that we easily have a quality controller in Italy. I mean, typically every family has a quality controller. And if you cook something and you try to do yourself something in Italy, you always have someone on top of you that will check what you're doing and is always ready there to criticize what you have just done. That's why I call this additional step mother-in-law final check. So this mother-in-law, in fact, is a quality controller that once the pizza is about to be presented, then can raise different exceptions. So for example, can raise a need more ingredient exception. And in this case, the flow is redirected to the ingredient topper. Or it can raise an exception like an uncooked exception. So the flow is redirected to the baker, so it will go into the oven again. Or if it's overcooked, of course, the flow will go into the bin. It cannot be presented. Or there's another kind of exception that usually you find with this mother-in-law final check. And this exception, can't you see I'm doing other more important thing exception? And this is an exception that, of course, means that it's better that you retry later. But let me show you this one in code. And this is something that I haven't shown you before into the task definition. So here we go. So we have seen previously how to define a state into the AWS Step Function. And this was typically where we stopped. So we saw there's a name of the state, there's a comment, a task in this, a type in this case was a task, a result path, so state machine data, a resource, which was the lambda that we call, and the next. But we haven't seen this section before, which is the retry and the catch. And I want to zoom in this section, and I want to show what is going on here, what we can configure in this particular section of the state definition. So here we define a retry. So what I'm actually saying here is that if out of our function execution there is an exception that is, can't you see I'm doing other more important things exception, I want to wait for an interval of 5 seconds and try again. And you can configure the max number of attempts and a backoff rate. So when you call again the same function, AWS Step Function makes sure that the same input parameter, exactly the same input parameter, are passed into the function itself. So another configuration thing that I wanted to show you that is essential, so retry and catch, they go in pair, is the catch, in fact. In fact, suppose that I've exhausted the number of retry here, where do our step function, where do our flow goes? Here, I tell this inside the catch section. So I'm saying, you know, you try this many times, and then once you finish, if you still see this exception, then the next state is going to be bin. But I can even configure in the catch all those exceptions that I don't want to retry. So for example, the exception that determine a new path in the flow. So for example, if I see need more ingredient exception, I can see that the next step is going to be ingredient stopper. Or if my exception is uncooked exception, then the next step is going to be the baker, and so on. And here I can highlight like a catch-all exception, or a catch-all exception name for the states inside the step function, which is states all. And of course, if you want to, if your exception is one of those states all, is one exception that was not considered before, I want my step function, my state machine, to end with error, which is another state. This was a convenient state that we did just to log that the state machine has finished with error. Now, let me tell you some consideration that we have done while developing with some compromise that we have seen while developing using step function. So we have seen that step function offer a great flexibility, easy to accommodate workflow change. But this, you know, the consequence, the other side of the coin of this is that the state machine is growing a lot and easily. It's so easy to make change to the flow that you don't realize when the state machine grow much. Now, this is our state machine inside Tesco that we use. It has grown. It's not. We don't consider it at that level that we can split it as yet. But for example, this side of the state machine will prevent you from properly seeing the flow. So you cannot actually clicking easily or see where the flow is going. We have remediated to this using actually the console, the command console, and see and follow the flow from there. But you know, there are remedies for this. So for example, you can split into different step function, and maybe having one state actually starting a new step function as opposed to, so for example, isolated all this inside the new step function. Of course, trying to find a logical isolation. So another thing is easy to explain. That's a positive thing, but also there is no, there are different ways to achieve the same thing. So there's no a well-established pattern to follow. Maybe because step functions are quite new, but there's not an easy pattern to follow, a well-proven and tested pattern to follow. So another thing, another aspect to consider is the exceptions are handled by the infrastructure itself. So you define the exception handling inside the step function definition, but they just handle runtime Java exception. So if you have a checked exception, that need to be caught and reshowed as runtime or something else. We try to avoid this kind of we try to avoid having checked exception there. So another thing that we notice is that you see before I've told you about a states all exception that is basically a catch-all exception that were not declared before. So if instead of states all you define like state all, so there is like an error here, the S is missing. There is no type check in the exception handling. So you may end up, writing state, but you may just realize that you have made a mistake at runtime. And also, there is no check if the exception is actually thrown or not. So we may end up with a list of exceptions that actually the function does not throw anymore. Another thing is that the flow is implemented in the infrastructure. An important aspect is the flow is implemented in the infrastructure, but how do we integration test it? So now our workaround for this was like to define a lot of, because our function called the endpoint, we define a lot of mock server, and then we were able to test the flow via using the mock server. So the mock server would expect a call, a specific call from a function, and then we can count the number of times the parameter and the parameter use in the mock endpoint. Code injection, so is because we are talking about Lambda, is better to have, of course, for code injection, we need to build some kind of dependency graph at one point. We find out, of course, that all the for example, Juice or Spring that use that build the graph at runtime using reflection, they're not really suggested because we will waste time, we will pay more, and every time that we execute a Lambda, we need to rebuild this graph. Instead, we find very useful Dagger 2 that build the graph at runtime time, at compile time. So at runtime, you don't have to build the graph dynamically. Other challenge that we face, we had the 25,000 entry limit in the execution history. So in that list that I was showing you before, where you see all the states that were executed, there is a limit of 25,000 entry. So there is a known workaround for that, but still I don't think it's fixed at the time of recording this. And the output of the AWS Step Function itself, so the whole Step Function is not in CloudWatch. We found this a little bit annoying as well. Okay, we are about to wrap up here, but how much is a Margherita pizza? So let's talk about cost. So we have 4,000 state, so it's charged per state transition, and then this is what is charged the Step Function, and then of course, depending on what you run inside the state, that it's separately, that is charged separately. And there is a free tier of 4,000 state transition, and then you can buy like another 1,000 state transition for $0.025. So you can imagine now we have taken with our inside my team, we have taken the decision of going with Step Function as opposed to go for a microservice for doing all the processing that we needed. And you can imagine our faces when the HFSD, Head of Software Development, ask us, okay, are we actually saving money using Step Function, or we are ending up spending more than we would have spent if we were using like a process, a batch processing microservice running continuously, for example, in a EC2 instance. We were speechless at the time. We couldn't check how much was spent to run the AWS Step Function accurately, but then the HFSD came back to us and he showed us this graph. So basically, what these graphs tell us is that we spend in 3 months of activity, we spend about $100, executing the step function as opposed to keep the process running all the time. And this is good because $100 is probably the price of just one EC2 instance for this period of time. So at the end, for us, the choice was correct. And with this, I finished my presentation. So if you have any question, please ask, or I will go to the.
Yeah, hi Mario. We thanks very much for that. That was awesome. I am now very hungry as well. But we do actually have a question that was sent through initially when people signed up. So bear with me. Sorry. So yeah, this one says, I'm trying to use AWS Step Functions to create parallel branches of execution. One of the parallel branches starts another step function invocation. How can we pass input from this parallel branch to the next step function execution?
Yeah. So we have used the input path to do that. So so the input path is something that we filter the data, can select the data from the state, the machine data, the state machine data, and you can select exactly the data from this state machine data and pass into the new step function. So using input path is what we've used.
Okay, perfect. Hopefully that answers that question, but say it was one which was sent before, so not sure. We've got one here as well. Can we enable logging in CloudWatch for an AWS step function created via Terraform to track individual states?
Yes. So so in CloudWatch you automatically have the logging of each function inside the AWS step function. So that's what we have seen. So automatically all the logging thrown out by the AWS by the function, by the states, they automatically go into CloudWatch. And basically the process that I've shown you with the serverless framework is basically a layer on top of CloudFormation, and this is what Terraform does as well. So the end result is CloudFormation is done there in the same way as we do with the serverless framework.
Okay, perfect. So that's that done. Are there any more questions from the audience? Okay, it sounds like that's it. Well, Mario, thank you very much for that. That was extremely interesting, and I love the quirky take on it. Very, very interesting. Just remains for me to say thanks very much again, and thank you for everyone who's joined us on this. Of course, the recording will be up on our YouTube page later on this afternoon, and if you have any other questions, please do feel free to contact Mario or myself, and we'll be happy to help on those. Finally, always keen to hear about more ideas for more of these sessions, or indeed panel discussions on any technology that you might be keen to discuss. So please come to me or our community lead, Becca, to discuss these. Anyway, have a great day. And Mario, thanks very much.
Thank you for having me. Bye-bye.
Pleasure.